We talked in the last lecture about how Hubble discovered this relationship between the velocity and the distances of galaxies. And in studying the velocities, Hubble made another discovery that was pretty surprising. He also found that when he studied the spectra, almost all galaxies had a redshift. That means that they're all moving away. There were a few that didn't. The ones that didn't all happened to be ones that were really, really close, like the Andromeda Galaxy, like the Large and Small Magellanic Clouds. Those were moving towards us. But other than that, everything else seemed to be moving away from us. And this was a pretty surprising discovery. After all, if everything is moving away from us, does that mean like there's something weird about us? Like, say, we're the center of the universe and there's something strange about our galaxy that makes all the other galaxies go away? That would be pretty bizarre if that were the case. After all, every time we have assumed that we're the center of the universe, we've turned out to be wrong. You had people who thought that Earth was the center of the universe. They thought that the sun went around Earth and all that. Well, that turned out to be wrong. We went around the sun. For a while, people thought that, well, maybe the sun is the center of the galaxy and all the other stars go around the sun. Well, that turned out not to be the case either. We're halfway out from the center of the galaxy. So why should our galaxy be special? Why should everything be moving away from us? This was a sort of puzzling question. And the answer that seems sort of surprising, but has since been shown to be correct, is that the galaxies aren't actually moving. They look like they're moving, but the reason that they seem to be moving is because the space in between them is getting bigger. This is something that fits very nicely with Einstein's notion of space that we studied when we talked about black holes. Space can be warped and bent and moved around. It's not something that's fixed. The coordinate system isn't fixed. It's like the coordinate system is getting bigger. If you look at this imaginary little situation, so these little dots on the coordinate system represent galaxies. And if the coordinate system gets bigger, if you stretch it out, then the galaxies get farther apart, which is exactly what Hubble would predict. And again, I mean, just watch it. I can make the galaxies get farther apart. I can actually change my, should be able to change my size. Here we go. You can see by stretching this out, the galaxies are getting farther and farther away from each other. So that's what's really going on. This space is getting bigger. That's a really bizarre thing to think about. When I talk about this, people are always like, what's it expanding into? Well, that's not really an answerable question because the space is everything that we know. We're talking about the universe here. The universe includes everything. How can the universe expand into something that's not the universe? There isn't anything that's not the universe. The universe is defined to be everything. So what is it expanding into is not really an answerable question. All we know is that the space is getting bigger. Why is that happening? Well, that's something we'll have to postpone until another lecture. But the space is getting bigger. An analogy that people often use, and that's why I put this picture on here, and we're going to do a lab with this, is think about a balloon and imagine that you paint some galaxies on the balloon. You even draw a coordinate system if you want to in this picture. And then you start blowing the balloon up. In that case, the galaxies get farther and farther and farther away from each other because the space, which is represented by the surface of the balloon, is expanding. Now, again, of course, the balloon has something to expand into that's not the balloon. The universe doesn't. But nonetheless, it's expanding the space. Now, does this resolve the question that we were talking about are we special? Well, yes, it does. You can be sitting on any one of these galaxies, And if you start expanding it, all of the other galaxies are getting farther and farther away from this one. But imagine instead that you're sitting on this galaxy. Well, as we blow up the balloon, all of the other galaxies are getting farther and farther away from this one. And if we sit on this one, well, all the galaxies are getting farther and farther away from this one. So it doesn't matter where you're sitting, it's always going to look like everything is moving away from you. The way we would account for the close by ones getting closer to us is the fact that there is gravity between us and the nearby galaxies, and the gravity is stronger than the expansion and is pulling those guys together. But anything that's not really close by, that's too far away to be seriously influenced by our gravity, those will expand away from us. So this is the concept that the galaxies aren't actually moving. They're staying in the same place in the coordinate system. It's that the coordinate system, the space, is getting bigger.